So today let us see one of the DP problem, that is uh, Stinkler thief. The thief wants to loot money from a society having n houses in a single line. Okay, there is n houses in a single line. He is a weird person and follows certain rules. That is when looting, while looting the house. Okay, according to the rule, he will never loot two consecutive houses. Right? The same time, he want to maximize the amount he loots. The thief knows which house has what amount of money, but is unable to come up with the optimal looting strategy. He asks you for the help. Okay, now see, the question is simple. You need to find the maximum of sum of non-adjacent element. Imagine you have three array elements, then you need to find the maximum of non-adjacent element. So you can't take 2 and 3 and you can't make it, you can't give result as 5. So you need to take non-adjacent, that is which are not side by side element. So 1 and 3 is the optimum result. So 1 plus 3 is 4. So in their test case also they have mentioned this one. See, for n is equal to 3, that means the array elements are 1 comma 2 comma 3. So 1 plus 3 will be 4. So similarly they have done this one. So this is how question goes. You need to find the sum of non-adjacent elements in an array. That's it, which is maximum that you need to return. So what I do is, see, I will explain you how it works. Imagine we have houses here. So we have houses. So these are nothing but what? Array elements you can consider as. So 1, 2, 3. So what you need to do is, see, imagine, let me increase the size of the houses, means number of houses. So there are like this, the my test case is this 1 comma 2 comma 3 comma 4 comma 10. That means if you the brute force will be, obviously you should use recursion, right? Because there are a lot of ways here. You can choose this one and you should leave this one, then you should choose this one, or else if you don't choose this one you should choose this one. Like that, there are many ways. When there are many ways, obviously you should use recursion there. Then through recursion I am going to use memorization. So that is what I will apply the DP vector. Okay, that is how I make I will, that is my brute approach. So first thing what I do is I will write the test cases, sorry, base cases. So what would be the base case? See, if n is equal to 0, what you will do? Or else let us take it as, if n, that is the index, actually what they gave, what they will give you is, for the n value, that is number of houses, right? Number of houses, but we need to represent in form of array, right? So I need to take 0, 1, 2, 3, 4 like that. Okay, then if they give 1, then what I should imagine, they will give n is equal to 1. So in my function I will do n minus 1, because if they give 5 to me, if they give 5 to me, so my index varies from 0 to 5, 0 to 4. Okay, that is what the approach is. So in this function what I make initially is, I will call for another function where I will apply the recursion. Here I will return, and I will return an array, and I will return n minus 1. So I'm using array, right? That is why I took n minus 1. So this is very much common in most of the problem, so be careful about this. People tend to give n here, right? By considering array they will give n. That means they are giving extra value to it, so that will give wrong results. So I will do that one. After that, imagine n is equal to 1, that means, sorry, n is equal to 0, means they have given there is a single house, that is what they have given. So what is the probability of looting more money? So it is simple. You need to return a error of 0, that's it. You need to just return that because it is obvious, right? There is only one house, so you can loot that your possibility is looting that house only. So let me return int, then let me write function, then I will take array, then int. So this is what I am going to do in my program. And then what would be my brute approach? See, what I will do is I will consider this. This technique is very popular, that is picking and not picking, or including or excluding. Imagine I will take this for me. So I already said that I will always be traversing from right to left. That means from fourth index to 0 in this case. Okay, what I will do is I will consider this index, means this position, this 10 I will consider, right? I will consider. If I consider this position, then which is the next position I need to consider? I need to consider n minus 2 position, right? I need to consider n minus 2 position if I pick this position, if I pick this value. So this is what pick means. What if I don't pick? Imagine I don't pick this one. Then what you can do? And then you can pick n minus 1, right? You can pick n minus 1. That is, here n is equal to 4. So what you will do is I will pick 4. Means since I don't pick 10, I can pick 4. So that is my probability. That is my possibility. So if I pick 10, then I won't pick 4. Then what would I pick? I will pick 3. So I will write that case here. Okay. If I don't pick 10, then I will obviously pick this one, right? This 4, right? Because I need maximum. That is what the approach here is. So if I consider, means I will take an array that is element, that is variable. I will call it as, it's a pick. So here I will call for the function. This means I have picked that value. So I will pass array. Usually here array has to be passed like this. So, okay. Then I will pass the array. Then since I have picked, what should I pick next? I should pick n minus 2. I can't pick n minus 1. So since I have picked n, then I will add that value here to the pick. So it is common sense, right? If I pick n, then I must add that to the recursion, to that value. Okay, then what? Then I will not pick. I will not pick. Then that is equal to, since I don't pick, I don't need to add anything. But what I do is n minus 1 I will do. That means since I don't pick n, you can go and pick n minus 1. So again, you can call this function, again recursion, we are going to draw recursive tree. Then I don't add anything, that is obvious since I don't pick. Then what I return? What I will return is max. So I should find the maximum, right? I need to find the maximum, so I will make it as max. Okay, this is what the function is. But if you observe, when n will be 0 or when n becomes 1, what will this function return? It will return negative value, right? So I should take care of that test case also, right? So that is why what I will do is, if it is less than 0, if it reaches less than 0, you do what? You will return 0. Means you don't return anything. That is what the function tells. So let me copy paste this thing here. Let me copy paste and I will, okay, paste it. So this is how I will write the code. Now let me align. Pick and not pick, but it will give TLE. Obviously it should give, because I have not used dynamic programming yet, right? DP yet. So I will close with a bracket. Then I think it should work. So I will compile this. So this is giving me proper result, but if I submit it, I don't get the proper result. I will get TLE. Okay, now you know how to add the DP. We have seen in the previous 2 videos of my dynamic programming. If you are not seeing, then you can go and see, and if you already know how to add dp, then no problem. How to add dp? I will take a vector, right? I will take a vector now. Now before dp, let me write a recursion. Let me do this. Let me write a recursion tree, so it will be easier. After that, we can look about the dp. So n is equal to 3, n is 1 comma 2 comma 3. So let me write the recursive tree for this. So from when n is equal to 3, that is function of 3 you are passing, means 2, right? N minus 1 I have passed. Okay, now I will take 2. Okay, now what it will call? It will call, okay, you go by the code. So this will not work. Again, this will not work. It will work. So pick, I should pick. What I need to do, I need to call function of 0. But I will pick, right? So what I need to do, so my elements are 1 comma 2 comma 3, as you saw in the test case, plus 3 I need to do. This is I will pick. Okay, now what? F of 1 will f of 0 will return what? F of 0 will return me error of 0. That means 1 it will return. Okay, 1 it will return. So I will return here. Then 1 plus 3, what it returns? It returns me 4. So actually before returning, we this line is not worked, so it will not return this yet. So it will return 1, then 1 plus 3 is what? 4. So let me write here as 4. Now this line is finished. You have worked with this line for n is equal to 2. Now for n is equal to 2, we need to work on this second line, not pick. So if I take not pick, then f of 1 I should write. Then I know I don't need to add anything because I am not picked, right? Then immediately for n is equal to 1, the function is called. So this will not work. Again, this will not work, and this will work. That is pick n minus 2. It will call, but what it does is it will add. So n minus 2 is what? F of minus 1. Okay, plus f of 1 is what? F of 1 is 1, right? 1. Then this will obviously return 0. So 0 plus 1 is what? 1. Let me write here 1. Again, for f of 1, I have not completed this second line. I have just completed the first line. That is why I got this left side of the tree. So let me complete the right side. So function of what? 0. Function of 0. I don't need to add anything because since I am not picking. So it will return me what? It will return me again. If it is 0, then it should return me 1. That is the first element. See here. If n is equal to 0, it will return me first element. So it will return 1. So it will return 1. Then what? This is 1 and this is 1. What is the max of? Then the third line for n is equal to 1 is executed. Both are 1, right? So no. This will return, yeah. 0 plus 1 is 1. So for this we have 1. And for this 1. So max of 1 is 1. So 1 will be returned here. So we have 4 here. So 4 and 1. Again, the third line will be executed for n is equal to 2. It is max of 4 and 1. And there is a maximum is 4. So I will get 4. So that is how recursion will work. Now I will add dp. Now how to add dp? I will create a dp vector. So vector. So they will be giving n range, right? So that n range is 10 power of 4. Okay. And dp, then 1 2 3. Let me take 5 extra size. Then what? Then minus 1. Then I will send dp. Then what? Here I will take the vector of int dp. So I will take the reference because see, I will keep on changing this, right? So again, this is normal common step. You will be knowing this one. If dp isn't of n isn't equal to minus 1, then what you need to do, you will return dp of n. Then what, while returning you do this one. So this is how it works. So let me compile, let us see whether it will work. Okay, we are getting compiler error because when we call this, right, we are not passing dp again. So that is what the problem here. So you pass the dp again. Okay, let me compile now. Now I'm getting the result. If I submit, I should be passing all the test cases. So I have passed all the test cases. Okay. Now this is about DP, dynamic programming problem. Further, I am going to solve much more problem here. So you can check on the playlist for other program. And I think it is so much useful. DP is the most important topic for if you are competing in any coding platform or even for internship and normal placement. In competitions, you'll be asking only DP problems. So let me end this video. Thank you.